This two-part build sequence is presented primarily as entertainment. So if you're serious about increasing your knowledge on the subject, seek information from other sources too. Build a few engines, see which methods work for you. Some YouTube posters gag their audience, disabling comments, but you may have something helpful to say. If you want to stick your oar in when you've watched, just make your comments positive. And if you don't find this entertaining, turn off. I won't be offended. There are several motorcycle books in my library which have been useful in general and specific ways. Pitman's offerings give basic information. The Motorcyclist's Workshop, written by Torrens, the motorcycle's Arthur Bourne, delighted me well before I owned a motorcycle and is still a useful reference for those working on old machines. But when it comes to Panther specific information, this one by Laurie Neal is indispensable. Reading it would have saved me a deal of trial and error 40 or 50 years ago when I broke the seal on my first Panther engine. You can get a copy direct by emailing the author. And if you're building your engine from a box of bits, this two-part video might just help you to identify that piece you've been struggling to fit. Maybe it will turn out not to be a Panther part at all. We begin here at the heart of the engine, a crank converting linear to rotary motion. I've already checked over the various parts for damage and cracking, not unlikely problems, given that we are assembling components made at least 50 years ago, and now 40 years beyond their best before date. And if you're wondering if it's worth the bother, here's what can happen when a conrod breaks. Everything's clean as a whistle. The crank pin, a taper fit on this Model 100, is tightened in a simple vise jig to about 30 foot-pounds. We encourage it to move a touch at this stage. Two rows of 5/16" rollers are stuck to it with grease, and the conrod eye slid on. Oil holes for the gudgeon pin are offset to the top of the sloping engine. This is the drive side flywheel, so be sure to get the rod the right way round. The fit is snug but free to rotate. Put on the timing side flywheel with its tab washer and nut, and tighten that too. Some use a square at right angles across the wheels at this stage, but the human eye is capable of detecting a remarkably fine degree of misalignment. Many builders align successfully between centres, but to me there's an element of chance to this, and chance is something best avoided when putting together any mechanical device. We have no way of knowing how the parts have been brutalised over the past half-century. I fear that the drive side crankcase didn't survive violent removal of this crankshaft. Shaft centres had a function during manufacture, but they have no part to play in use. It's the shafts themselves where the bearings fit and where the timing shaft enters its outrigger bush, which must be in alignment. PVC tape restrains the conrod and we're ready to roll. My jig is homemade, the shafts sitting on roller bearings at the inner ends where they'll be supported in the engine. A dial gauge gives us the crank's wobble factor in thousandths of an inch, and we're aiming to get this figure below 2. Truing flywheels is a test of patience, as is anything where the law of diminishing returns comes into play. In principle, if it takes 5 minutes to halve that 30 thou run out, to halve the resulting 15 will take 5 times that, and so on. It can be fun to do, but for an audience, you'd prefer to be watching paint dry. If I kept the camera running for the whole process, you'd be fast asleep in minutes. A blow from a plastic or lead-faced hammer is applied to one flywheel, the other one resting on a convenient tree trunk. Set up like this with the gauge outside the bearing points, you have to hit the crank counter-intuitively, that is, in the direction that it already appears to be misaligned. I can't describe it better or tell you how hard to clout it. Trial and error is the novice crank truer's best friend. When you get below the magic 2 thou, run out at the shaft's end, tighten the nuts to 80 foot-pounds and check again before tweaking up tab washers, and then treat the assembly with the greatest respect. Crankcases are next on the agenda. This magneto drive bush is a sloppy fit on the shaft, and though new ones may be available through the POC spares scheme, I've decided to skim it and fit a thin bush. Heat the case, support it, tap out the old bush, skim its bore for a light interference fit with a thin wall inner, and press it in. A smear of bearing fit helps to retain it. Strictly speaking, best applied with a brush. And never clean your fingers on your overalls, or people will think you're the sort who wipes snot on his sleeve. This is the new bush being pushed in. Drill its oil hole. Check the fit of the drive shaft. Run a reamer through, and it's ready to be pressed back into the hot case. This is the traditional way to remove a little end bush, with a selection of small spacers and bushes, nuts and washers, all subject to gravity. And nowhere will you find more gravity than at the edge of a workbench. This is a good moment to measure the crank cheeks. The method I use saves fitting and removing bearings to set end float. Using a lathe with faced rods in chuck and tailstock, snug these up to the crank cheeks where the bearings will sit. Note the figure on the tailstock graduations. Remove, reset and measure the gap. Now, with the crankcase halves bolted up, use a bore gauge to get the measurement between the back of the bearing housings. Add the width of the two bearings to that and subtract the total from the case width. The difference is the end float, as is. Add shims to achieve around 10 thou clearance. Back to the crank and its little end bush. The new one goes in as the worn one came out, and this time without losing anything to the forces of gravity. It's an interference fit again, so the inside diameter reduces slightly under pressure. The pin will no longer fit. I told you. Not everyone approves of expanding reamers, but they work just fine if used with care. And if you only do the occasional job, a single reamer provides several different sizes for your money. Run a drill through the oil holes in this case, and it's done. Cases which appear clean can still have muck lurking in the corners. Chase out threads with the appropriate tap and push some rag through stud holes. You'll appreciate the trouble you took when studs and screws go together with ease. I have a bit of a thing about keeping the oil inside, and apply PTFE tape to fittings such as this oil drain to crankcase union. Panthers have a bad enough oil habit without encouraging them. This is a brass thread in aluminium. So I hold the ratchet spanner at the inner end to reduce leverage. And no, that wasn't a kiss for luck. Heads up, the exhaust valve seat is a trifle recessed. A cutter removes the ridge. I've previously fitted a new set of guides reamed to 3 thou clearance. In common with many other owners, I have been tempted to reduce this in the past and thought it successful until one hot day and the engine was working a little harder and a valve seized with a vengeance. Half an hour later, the engine still lacked compression. Before the days of mobile phones and a proper breakdown scheme, we begged the occupants of a nearby house to let us park the outfit on their drive for collection next day. We were about to set off walking to the nearest bus stop when I applied my boot to the kickstart one last time. Click. I rode very gently home and vowed to leave plenty of slop in the guides thereafter. Out with the fine grinding paste and lap both valves into their seats for an even grey finish before assembly. Wipe the paste off and put the rag in the bin to avoid contaminating bearing surfaces. In the bin. Oh. The new old stock springs were an auto-jumble discovery, one of those happy moments. A tap on the top to make sure the collets are properly seated. Heat is a friend when it comes to fitting bearings and removing them. Keep a propane torch on the move to bring the temperature up evenly. Somewhere between 100 and 200 degrees centigrade, the outer ball bearing should drop in, maybe needing a slight tap. This race secures with a circlip, so won't drop out when you turn over to fit the opposing roller race. Inner and outer must be separated for fitting, so mark the boxes to keep matching halves together. An oven is an alternative source of heat, assuming your workshop budget or your standing in the kitchen runs to it. It takes a little longer, but provides an even heat. This bearing took the merest caress from a mallet to persuade it in. With both outers in place and the cases cooling, we're ready to fit the relevant inners to the crank. A box spanner drifts one up to the shoulder of the timing shaft. This build only required a couple of 2 thou shims to set end float to an acceptable figure. If using several, it's best to distribute them to either side to keep the crank centered. The drive side roller race is not such a good fit. A badly worn shaft may be recovered by metal spraying if no replacement is available, but as there's no play here, I'm using a smear of Loctite 641 bearing fit. A spot of oil on the races, and with the timing side case supported on wood blocks, we can drop the crank in place. Choice of gasket goo is a personal thing. Over the years I've used Hermitite in original red and a veritable rainbow of colours. Hylomar and silicone, sparingly because you don't want stringy bits of that in the oilways, all have had their moments. This is well seal, which may be as close as you'll get to the old days when shellac was the manufacturer's choice. No need for lashings of the stuff, it goes on thinly with a brush. Drop the dried side case on and run studs through. Just nip the nuts up at this stage and check that the crank turns freely. a spot of oil on the ball race before we fit the shield and its thin circlip. Now lay the engine on its side and fit the engine rods and the saddles. The barrel and head can be bolted up to pull the machine crankcase mouth faces dead flush for an oil-tight joint before the crankcase studs are fully tweaked up. Then off with the head and barrel again, and we're ready for tea. Part 2 follows the build process to complete the engine for fitting into a motorcycle of your choice.